Okay, well, we could probably get away with one more problem because, we've been doing the happy minutes. We graded today, so tomorrow we don't have either of that, so we should be able to just get straight into the lesson. But what did we start talking about yesterday? How to solve what? Trig equations, okay. And what I was really trying to get you to see was that it was going to be done the same way that you're solving all those other equations from years past. Just multi-step equations, maybe factoring, some kind of algebraic technique, and you can even use identities to help you simplify an equation. All right. Now the key here, every single one of these problems that I give you, okay, is going to be based on special right triangles. Okay, so what kind of special right triangles am I referring to? The 45-45, okay. And these are horrible looking triangles, but just got to go with me. And the other one is 30-60-90, right? Okay. Well, the legs of a 45-45, they're always of identical lengths, okay? So that's one characteristic you could be looking for. But how do I get the hypotenuse? What's that, sir? Oh, am I out of copies? Over there. I don't believe I have any extra copies. I could probably print one up for you as soon as we're done. No, I'm sorry. No, you're fine. It's okay. I'm sorry. But I will get you one. Okay. All right, so what would I do to one of those shorter legs, x, to get the hypotenuse of this triangle? I got to multiply it by something. Oh, not just 2. Square root of 2. So if I take the leg, multiply it by square root of 2, that's the relationship we're looking for in that triangle. Now, in the 30-60-90, we multiply that shorter leg x by what to get the longer leg? It's also a radical. Square root of 3. So the shorter leg times square root of 3 is the longer leg. The shorter leg times what is the hypotenuse? 2x. There we go. The hypotenuse is always double. So those are the characteristics that you're going to be looking for. So all of these problems will work down. They should be giving you a special right triangle. The only exception, if you can't draw a triangle, that means it's a what? Starts with a Q. Quadrantal. So you'll be looking at those axes. Okay. It's got to be one of those 3. Okay. I'm not going to be giving you any that don't work that way. Okay, so the big thing here was just to isolate the trig function. That's the first one that we're taking a look at. Well, let me go ahead and go on over here. Okay, so let's solve this one. 2 cosine of x minus 1 equals 0. So if you have an equation with just a single trig function, a really good idea is just to pretend it's a variable. Get it by itself. So I want to rewrite this so that the equation just says cosine of x equals. Okay. So just pretend it's like a normal equation. What would I do first? Yeah, any additional terms you want to add or subtract to get them over. Okay. So in this case, I'm going to add 1. Those are going to cancel. So 2 cosine of x should equal 1. There you go. And then now divide by any coefficient you may have out in front. Okay. So those are going to cancel. So cosine of x is equal to 1/2. Okay. There you go. Now, I mentioned something yesterday. Whenever you get it down to this point in the equation, it'll be equal to some kind of value, typically a ratio, some kind of fraction, because that's going to represent the sides of the triangle, right? Well, because this is positive, why is this diagram here showing me 1 and 4? What's that phrase that I taught you to help you remember where they're positive and negative? All students take calculus. Okay. So what 2 quadrants will cosine be positive? 1 and 4. So see, like on the first problem we did yesterday, where was sine positive? Quadrants 1 and 2. That's why we had those there. Okay. So let me go ahead and recreate this diagram that we have. Okay. So we're going to draw a triangle in both quadrant 1 and quadrant 4. So a good rule of thumb, I've got 2 triangles. So how many answers should I have on one interval from 0 to 2 pi? Two answers. Okay. So let's see. We always go from the reference angle's point of view. Remember, cosine is what ratio? It's always x over r. So this would be 1, while the radius of each would be 2. And remember, that's one thing that's really nice about these triangles. No matter how many triangles you have to draw, they will be the exact same triangles over and over and over again. Okay? So if this is 1, this is 2, what's that height? Can anybody tell me? Not 1. Let's say we don't know. How can I find out? Pythagorean theorem. So let's say right now I want this y right here. So that would be 1 squared plus y squared is equal to 2 squared. So 1 plus y squared should equal 4. Subtract that over, so y squared equals 3. So it's got to be the square root of 3, right? Okay. So square root of 3. Now, because this one's in quadrant 4, that would be a negative square root of 3. Remember, the negative just tells you direction. Okay. Now, remember what I said? If these don't create a triangle, it's got to be a quadrantal. But we got a triangle. In fact, what special right triangle did I get? 30, 60, 90. The only question, this angle right here, the reference angle, is that 30 or is that 60? It is 60. What side is directly across from it? Is it the shortest leg or the longer leg? Well, let's see, my two legs, I've got 1 and square root of 3. Which one's bigger? Square root of 3. So if you're across from the longer leg, that's got to be 60. So that's 60. What's that, Brandon? You know, actually, that happened when I was young as well. They ruptured. They came in at an angle and they ruptured, which means it broke the surface of the gums. They were actually coming through. And they were coming in at an angle and they were putting pressure on my upper teeth. So that when I ate, I mean, it was excruciating. So I ultimately had to have surgery to have them removed. They had to get those out. To have my wisdom teeth removed, yeah. It's an experience. And, you know, because they take out those teeth, for a good while after that, you're going to have these holes, these pits, and every single time you eat, you're going to have to shoot water in there because you don't want any residue to collect, because that could lead to an infection. Mm-hmm. Yeah. And you can believe me, that's the tooth.
What did they put you in that stuff?
We're talking about teeth. Okay. I'm sorry, Leslie, what? I was making a stupid. Can you get amnesia?
Did they put you into that?
Oh, anesthetic. Anesthetic. Yeah, amnesia is when you lose your, like, you forget who you are. Yes. That is something completely different. I lost my teeth and I lost my identity. There you go. I'm sorry, man. Mm-hmm. But I mean, you're knocked out for, or at least I was for the entire thing. I mean, I guess some practices nowadays they can just shoot in locals and maybe numb it. But I would imagine probably the better way is just to put the patient under. Yeah. Mm-hmm.
I saw this video. It was of this YouTuber named Morgan Adams, and she got her wisdom teeth removed. And her brother was reporting it, and then after they're taking her out of like the dentist area, but she was still a drug dealer. So they had to wheel her out in a wheelchair, and then she was like, "Bye," and then the lady at the front desk didn't say bye. She goes, "How rude!" And she was just like over there acting like you're tough and everything. Come out here, and then she was upset. She goes, "You steal my money and you steal my teeth," and then she fell down.
Oh wow. Oh, wow.
I don't want.
Okay. Well, let me go ahead and finish up this problem real quick. Okay. Now remember, where do we always start rotating from? The positive x-axis, standard position, right? So starting here, I want to rotate to here. That's one answer. And then I'm going to rotate until I get all the way around to this guy here. Well, think, if this is 60, This has to be 60 as well. Remember, the two triangles will be identical. So here's something that I like to do. Every time I draw the diagram, I always go ahead and write out the answers in the degrees. So I know that one answer is 60 degrees. Okay, so think about it. What would 360 minus 60 be? 300. Once you have those degrees, the only step left is just rewrite them as a radian. I forgot the word for a second. Okay, so what's 60 degrees as a radian? Pi over what? 3. Okay, and somebody help me out with 300. So what's 300 as a radian measure? 5 pi over 3, that's right. We want to put our answers, our final answers, in radians. Now remember, this is the way that I'm going to go through it. I really want to emphasize the triangle method because I think it's going to give you a better understanding of really what's happening. But you can also do this. Remember, we got cosine is equal to 1/2, right? So look at your unit circle. Let me take this off right here. Okay. Everything I told you is either going to be a triangle or quadrantal, so it will appear on the unit circle. Cosine is the x value. So look at all 16 of these ordered pairs. Where do I have ordered pairs where the x value is a positive 1/2? There you go. There's the 1/2. There's the 60 pi over 3 that we just got. And the other one, there's the other positive 1/2 at 300, 5 pi over 3. It's just like any other equation. You're trying to find every answer that makes it true when you plug it in. Okay. So if you feel pretty comfortable using the unit circle, please feel free to do so. I'm going to really try to emphasize the triangles, though. Okay. Anybody having a hard time? Questions? All right. Well, that's all we got for today. Tomorrow we'll actually be able to do the whole thing without happy minutes or all that